Let's conduct a hypothesis test and take a look at what it looks like. We're gonna, first of all, look at the claim about population proportion. Just a reminder about the notation. P is population proportion of success. Q is population proportion of failures, which is a complement of proportion of success. Now, P hat is a statistic, right? These are parameters, and P hat is a statistic because it describes characteristic of a sample. P hat could be either given as a percentage in decimal form, or if it's not given, but we know the sample size and we know the number of successes, we can figure it out by dividing the number of successes by the sample size. Okay, the requirements, in order for this procedure to work, we need a simple random sample for figuring out proportion of the sample. And the number of successes and failures are both greater than 10. So making sure that we are looking at the normal distribution. So the proportions, sample proportions, follow a normal distribution. Therefore, we're going to get our critical values and our p-values from a normal distribution. This is important, guys. And our test statistic is also going to be a z-value, which is a value from a normal distribution. All right, so this is the formula that we're going to use for our test statistic. All right, let's take a look at this example. It says the ABC News poll was conducted on March 18 and 19 of 2020 among a random national sample of 512 adults. In the poll, 282 Americans approved of the president's management of crisis. At 10% significance level, tests the claim that the majority of Americans approve of the president's management of the crisis. Okay, so first, let's identify the claim. What is the claim here? If you need to pause the video, do so. And I want you to actually try and find the claim by yourself, identify it by yourself. And we're gonna continue. So the claim is there. I mean, there is a word claim that gives the claim away, right? So the claim is that the majority of Americans approve of the president's management of the crisis. Now we need to write this in mathematical expression. What does the majority mean? A majority means more than 50%, correct? So that's a claim that more than 50% of Americans approve the president's management of the crisis. So the claim is that P is greater than 50%. 0.5. P is greater than 0.5. Now the question is, does the claim go into the null or the alternative? And the answer is it's going to go into the alternative because it doesn't have an equal sign. So the claim goes into the alternative. Remember that our null is always P equals 2. All right, we set up our null and alternative. Now, what's the significance level? Well, it says at 10% significance level, test the claim. Okay, so significance level is 10%, and this means that alpha is 0.1. Also, at this point, let's figure out whether we're looking at a left tail test, right tail test, or two tail test. And that's where you have to ask yourself, what are we trying to prove? Well, we are trying to prove that P is greater than 0.5. So that gives us a right tail test. All right, the assumption is whatever you wrote in the null hypothesis, that's your assumption. The assumption is that P is actually 50%. Now we're trying to prove that it is greater than 50. So we want our test statistic to, if it just logically, let's think about it logically. If P is greater than 0.5, then your test statistic, the information from the sample, should be greater than 0.5, and not just greater, but significantly greater. So it's going to fall in the far right, on the far right from our 0.5, right? So it's going to be an unusually high value compared to 0.5 in order to prove our alternative hypothesis. So this is important, guys. So our value from the test should be unusually high. So if this is true, we need an unusually high value in order to prove the alternative. Okay, so keep that in mind. And but at this point we have a right tail test where, so now the question is, what constitutes an unusually high value? Well, that depends on a significance level. And significance level basically gives you the probability. So this is the probability of 10%. If the probability of that high value is 10% or less, then it's unusually high. Okay, so if our value falls in the top 1% right here, then we're going to consider it unusually high, enough to prove that alternative hypothesis is true. Okay, so this is our setup. Now let's go to the test. First of all, what do we have from our test? From the test, we need our p hat. What was the proportion in the sample? And in the sample, we had 282 Americans that approved, right, out of 512. And that's approximately 55%. So we have 0.55. Now, okay, it is on the right-hand side compared to 50%. But the question is this significantly high? Is this really an unusual value, the 55%? In order to answer that question, we need to figure out the test statistic using this formula. Okay, so what is the z value? In other words, where would this value be located on the right side? Is it located here, close to the 0.5, or is it going to locate in the tail? Let's figure it out. Okay, I'm going to fill out that that formula. I'm going to explain where those numbers are coming from. So I copied the formula so that you can see it. The hint is P is basically your claimed proportion of the population. That's this P from the null hypothesis. That's what the claim is. P hat is what we get from a sample. So that's it's important to read these symbols correctly. That's why we practice doing it all this time, because this value is from the test, from the sample. This value is from claimed value of the population. Okay, so from the test we have 55%. From the claim of the claimed value of the population we have just 50. Now, under the root, we're going to have this, the population claimed value. Now, if proportion of success is 50%, that means proportion of failures is also 50% divided by n, which is the value from a sample. So this formula is kind of difficult because we have mixed values from the population and from the sample. So pay attention, what is what. Okay, let me put this into a calculator. I'm gonna show you how I do it so you guys can follow if you want. I actually calculate the denominator first because it's most complicated, most complex. So I multiply the numerator first, and I divide it by the denominator. I could do it in one line as well, it doesn't matter. Okay, and then I take a square root of that value of the answer. Okay, and then I open parenthesis. That's important. You need to open parenthesis because the fraction bar is actually a grouping symbol. So it's a group, 0.55 minus 0.50. I'm going to divide by whatever I got for the denominator. So just answer. This way I don't round anything. My answers are exact. Okay, so I got 2.26 approximately. For z values, it's okay to round them to 2 decimals or 3 decimals. 2 decimals is usually okay for the z value. So this is my test statistic. Okay, now the question is this an unusual value? We can figure it out in two ways. Well, first of all, the z-score of 2.26, remember our usual values are within 2 standard deviations, and z represents the distance from the middle in terms of standard deviations. So this is more than 2 standard deviations away from the middle to the right side. Now the question is, how far to the right is it? Does it fall into this 10%? And there is 2 ways to check that. Okay, so we're gonna have our p-value method and we're gonna have our traditional method. So for this example right now, I'm gonna use a p-value method. So we're gonna compare, we're gonna actually look at the z distribution and see what percentage of values is to the right of 2.26. So here's my normal calculator with the mean of 0, standard deviation of 1. I'm operating with z values, and my z value that I got from my calculation was 2.26. So as you can see, we have a 1% of values to the right of 2.26. So that red area right there is a little bit slightly bigger than 1%. That was actually our p-value. So for the p-value, we're gonna write that value that we got. I'm gonna round it to 2 decimal places. So, and the p-value is 0.01. approximately. Okay, so where is this in our picture? That's 1% on the right, in the right tail, because it is a right tail test. So we put the p-value depending on what kind of a test we got. And our z-value actually is positive, so that also tells you that you're on the right side. Actually, yeah, the test statistic is what you're gonna go for. Okay, so, and it's the right tail test. So to the right of 2.26, we only have 1% of the values. So the question is, did we get an unusual value? And the answer is yes, we did get an unusual value. Now, in general, how do you make your decision? What's the rule for the decision? And so here, let's write our decision or conclusion. Sometimes I call it conclusion, sometimes I call it decision. It's reject the null, because we got an unusual value that supports the alternative, and we're gonna accept the alternative. Accept the alternative. So in general, the rule is this: if p-value is less than alpha, then we're gonna reject the null and accept the alternative. If this does not happen, if the p-value is greater than alpha, then you do not reject the null. Okay, now the probability that your p-value is going to be exactly equals to alpha is practically zero, so no need to discuss it. If you run into that problem, let me know and we'll talk about it. Okay, next, so we rejected the null and accepted the alternative. Now we need to interpret our result, basically give report back about our funding. So what did we find about the claim? So your interpretation is going to be about the claim. So what's the claim? The claim is here that the majority of Americans approve the president's management of crisis. It was also in the alternative, and we got the support for it, right? So the data actually supports the claim. Now the significance level is important. So what you're gonna write will be this: at 10%, you're gonna start with stating the significance level. At 10% significance level, we have sufficient evidence to support the claim that the majority of Americans approve of the president's management of the crisis. So that's how you go about testing your claim. Let's summarize the steps again. So first you identify the claim, identify the null and alternative hypotheses, identify significance level. That should be in the body of the problem. Then you're going to use the test statistic to find where the value from the sample falls. So we're looking for, is it going to be an unusual value or not so unusual value? Only unusual results will support the alternative hypotheses. So the p-value basically is the probability of this test statistic, given that the true proportion is really 50%. So if this proportion was really 50%, then it's very unlikely that we would get that result from the sample. That's what we got, okay? An unusual result. And if the result is unusual, that means, and it's on the right side, in this case, we have a right tail test, and our test statistic fell on the right side, and it is unusual. That proves our alternative, or supports the alternative hypotheses. So we have this basically constellation of things that support our alternative hypothesis. So it has to be an unusual value, and it has to be unusual value on the correct side. In this case, it's the right tail test. Okay, then because we got enough support for the alternative, we are rejecting the null, accepting the alternative, and then stating our conclusion. And this is the formula for your conclusion. You're gonna first mention the significance level, and then we have sufficient evidence or we don't have sufficient evidence, and then state what the claim was. All right, so I hope this is clear. If not, let me know. I'm gonna do my best to clarify things for you. And in the next video, I'm gonna talk about the second method, the traditional method, and I'm gonna base it on this problem. So keep it handy for the next video.